Hey Bobcats, we are going old school today. I was planning on having you work in IXL, working on problems, these word problems, and just from the feedback that I got from you guys over the last couple of days and from the Zoom meeting I had yesterday, it seems like you're not even sure how to approach these problems. So what I'm going to do is instead of working in IXL today, I've recorded a lesson for you. I'm going to give you some tips on things to look for in these word problems and how to decipher them. And then I'm going to do, I'll do an example, and then you can practice that same type of problem on your own. Now, there's so much writing involved with word problems that I went through and wrote the word problems in before we started this video. So if you want to take really good notes and actually write down these word problems, you're going to want to pause it as a new word problem is revealed and then write it down. But I don't mind if you don't take perfect notes, but I do recommend that you at least write some things down, okay? So here are some quick tips for you, things that you're gonna do. The first thing you wanna do after you've read a problem, well, first of all, read the problem. Okay, the second thing that you're gonna do is you're going to identify the two unknown things. It's going to change from problem to problem. Sometimes it's going to be, honestly, it really is so different from problem to problem. It could be hours and money. It could be number of shirts and cost. I mean, it just totally depends on the problem. But the thing that is constant with all of these systems of linear equation word problems is there will always be two things that we're looking for, two unknowns. And if you have two unknowns, then that means you have two equations because you can't solve it unless you have two equations. So after you identify the two unknowns and then give those unknowns names, so here, I'll put this here, give variable names to those unknowns. Okay, then you're going to write your equations. Now, to write your equations, you're going to be looking at the information given, and you're going to try to pull it apart into two separate categories. So now that I've kind of just outlined this, and it might not make total sense right now, we're going to put these principles into practice with an example. So if you are taking notes and you want to write these problems down, go ahead and pause it now and write this down, and then we'll get started. All right. Example, Chilton's PTC wants to sell t-shirts as a fundraiser. The shirts will sell for $8 each, and they cost $4 each to make, plus a $160 setup fee. Determine when the cost will equal the income. Okay. So what happens is, they are basically investing money here. They're paying $160 just to start making t-shirts, and then they pay $4 for each t-shirt that's made, okay? And they sell them for $8. Well, if they only sold one t-shirt, then they're gonna be in debt. They're gonna be losing money on this deal because they had to pay that huge lump fee at the beginning. So they need to sell a certain number of t-shirts to make up for the cost of making the t-shirts. So what we're gonna do is we're gonna first of all, identify those two unknown things. It looks like we're looking for cost, the total cost. The cost and the income, we want to find out when they're the same. So that before that point, they'll be in debt. After that point, they'll be actually making money. And the other thing we're looking for is how many shirts they need to sell. So our two unknowns, unknown number one is cost. And we can give that a variable name of C. And we're also looking at the number of shirts. We'll give that a variable of an S. okay? Now that we know the two things that we're looking for, we're gonna create our equations off of that. So let me come over here and start with the first equation. Okay, to determine the cost, first of all, how much is it costing the PTC to make these shirts? To find the cost, we know that it's going to be a $160 setup fee plus $4 for each shirt. Whenever you see the word each, that's our reoccurring fee. Every single t-shirt is going to cost $4. So since our shirts we're using as a variable of S, we're going to multiply 4 times S. So if you sold 100 shirts, that would be $400, okay? Plus that $160 fee that it cost to get started. Next, we're going to look at the opposite end of that, which is the income. Okay, so we have the cost, and now we want to take a look at the income. And remember, we want those two things to be equal to each other so we can figure out at what point does the PTC stop losing money and then start making money again. How many shirts does it take to get there? So we're going to use this C for the cost, okay? And in this case, they make $8 on every single shirt. So that each tells us that it's the reoccurring amount. So we're going to do 8 times the number of shirts they sell, okay? Now, I get the feeling that you guys are fine once you get here. You know how to solve a system of linear equations. It's just getting these equations that's the hard part. So I imagine at this point you can probably solve it just fine. So if you want to fast forward through this part, or if you want to pause your video and do it and then just check your answer, you go for it, okay? This is also a great problem to graph. Getting to see this on a graph is very powerful. So I might just do both things. First, I'm going to solve it with a system of linear equations, and then I'll show you how to graph it. So what I'm going to do is I'm going to take what I know C to be, and I'm going to plug it in here for that C. So what we end up with is 8S is equal to 4S plus 160. I can solve this. I'm going to subtract 4S from both sides. So I get 4S is equal to 160. Divide both sides by 4. And you can see that the number of shirts that they need to sell is 40. Okay? This has actually answered our question now, because when we get to 40 shirt sales, that's when the cost is going to be equal to the income. But let's go ahead and see what that income or cost will be by plugging it back into these equations. If we do, if you plug it in here, 4 times 40 is going to be 160. 160 plus 160 is going to be 320. So we're going to say this is $320. Okay, so they have to sell at least 40 shirts before they will be able to start making any money. I do want to take a moment and put this on a graph for you because it's so powerful on a graph. I have to say that I am now on my 4th ruler because my kids keep coming over to my work area and stealing my rulers, and then I can't find them. So here we are, ruler number 4. Okay, so let's do the number of shirts down here. And we'll do the cost here. And this is in dollars. Okay, so I'm going to make my scale something appropriate for 40 shirts. So this is 0. Let's go ahead and do maybe 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. And let's go ahead and make the cost. Let's go by 40s here. So 40, 80, 120, 160, 200, 240, 280, 320, 360, and 400, 440. Okay, so here's what we know. These are set up perfectly for graphing, by the way. Whenever you're solved for one variable, it definitely lends itself to graphing. So first of all, let's look at the cost of the shirts. It starts at 160. So even if they sell no shirts, it's 160. And then they sell they pay $4 for each shirt. So if they were to sell 5 shirts, this would be 20. This would be 180. If they were to sell 10, this would be 40, and this would be 20, or 200, I mean. And so it's going to continue on like that. Okay, so here is the cost line. This is how much it's costing the PTC. Now let's look at the income, how much they're going to make off of this. So that's the second line right here. Well, if they sell 0 shirts, they make no money. If they sell 10 shirts, they make 80. 20 shirts will be 160. 30 shirts will be 240. 40 shirts right here is going to be $320. Okay, so here's what happens. They don't make any money until they get right here to 40 shirts. This is the break-even point. This is where they go from being in debt to then making money, okay? Now, after this point though, you can see that this is the, sorry, I forgot to write it on here. This is the income. The more shirts they sell after this point, the better, because it continues to pull away from that cost line, okay? So to answer this question, the cost and the income will equal each other when you have sold 40 shirts, and that will get to $320. Okay, before that, they don't make any money, they're in debt. After that, they do make money. All right, now what I'm gonna have you do is I'm gonna have you try a similar problem on your own. So please take a moment, pause the video. If you wanna write this problem down, you can. If not, then just go ahead and solve it. And then I will go over this problem in just a moment. Okay, I haven't left myself much space here, and I'm going to go ahead and go over this problem now. Misha is the manager of a video store. It's so funny, they don't even have video stores anymore. Do you guys even know what a Blockbuster is? I don't know. Misha is the manager of a video store. She buys videos from a wholesaler that sells them for $8 each. The wholesaler also charges a fee of $200 for each bulk purchase. Misha then sells the videos for $12 each. How many videos does Misha need to sell to cover the cost of the videos? Okay, first thing we need to do is identify the 2 unknown things, okay? First of all, we need to find out how many videos, okay? So we'll say number of videos. Just like the last problem that we did together, we're looking for that break-even point. When does the income cover the cost of those videos? Let's go ahead and use a V to stand for the videos. Now, the other thing that we're going to be looking at, since we're looking at when the cost and income are the same, is that money piece, okay? So I'm going to call this cost, and we'll have C stand for that. At this point, you can, now that you've identified the 2 things that we need to know, we're going to write 2 equations to help us figure those things out. So let's go ahead and write our system. First of all, let's take a look at the cost. It says that there's a one-time fee of $200 and the videos cost $8 each. Okay, that each thing tells us that this is the reoccurring amount. So it's going to be 8 times the number of videos that she buys, which is V. But we also have to consider that $200 fee. And all that together is going to be the cost of this. The second piece of information that it tells us is that Misha sells the videos for $12 each. That's our income. And that each tells us that she's making that amount of money for every single video that's sold. So we're going to do 12 times V. And we want to know when the cost and the income are the same, so we can also set this equal to cost. Okay, I'm sure you noticed that I put my variables at the end, the cost at the end this time, and on the last problem I have it at the beginning. It doesn't matter which side you do it on. Sometimes it's easier to see that it's good for graphing if the variable's on that side, but it really doesn't matter. Now I'm just going to solve this one by substitution. I'm going to take what I know C to be and plug it in here for C. So this will be 8V plus 200 is equal to 12V. Then I'm going to go ahead and solve. I'm going to subtract 8V from both sides. And I'm going to get 4V. Divide both sides by 4, and I get that 50 is equal to V. So what that means is that Misha needs to sell 50 videos to cover the cost of the videos. So, and you can also just double check your answer by plugging it into both of them and making sure that the cost is the same. But we'll say Misha needs to sell 50 videos. Okay? All right, I hope this is going well for you. Let's go ahead and take a look at a different type of word problem now. Like I said before, I had to write these in so that I wasn't spending the entire video writing problems on a page for you. So if you need to pause it to write this problem down, you are welcome to. So Shannon is ordering lunch from Tony's Pizza Parlor. John told her that when he ordered from Tony's last week, he paid $34 for 2 8-inch pizzas and 2 drinks. Jody told Shannon that when she ordered one 16-inch pizza and 3 drinks, it cost $23. How much does a 16-inch pizza cost? How much does a drink cost? Okay, so we have 2 things happening here. We have John's order. He paid $34 for 2 18-inch pizzas and 2 drinks. Then we have Shannon, and Shannon paid $23 for 1 18-inch pizza or 16-inch pizza and 3 drinks. Okay, so and then it says how much does an 16-inch pizza cost and how much does a drink cost? Well, the question has answered some of this stuff for us because now we now know what we're looking for. We're looking for the cost of a pizza and we're looking for the cost of a drink. So those are our 2 unknowns. So the cost of a pizza, which we can call P, and we're also looking for the cost of a drink, which we will call D. Okay? Now, this problem is set up nicely because we have John's order, which is separate from Shannon's or Jody's order. So when we write our system, we can write an equation for John's and then an equation for Jody. So John said he paid $34 and he ordered 2 pizzas. Well, we don't know the cost of the pizza, so we're going to use P for that. So it's going to be 2 times P. He also ordered 2 drinks. And again, we don't know the cost of the drinks. So we're going to go 2 times D. And then the that's one equation, and now we're going to look at Jody's information. She paid $23. She only bought one pizza, so we're just going to put 1P there. And she bought 3 drinks, so we're going to do 3 times the amount of a drink, which is D. So now you have the system of linear equations, and I know that you guys are probably fine solving this, so if you want to skip this part and just check your answer, you're welcome to. I'm going to solve by substitution. So I'm going to take this equation, the second one, and I'm going to solve for P. There's no coefficient with it. It makes it a lot easier to solve for. So this is going to be P is equal to 23 minus 3D. Okay, so all I did is I subtracted 3D from both sides. Now I'm going to take what I know P to be, and I'm going to substitute it into this problem. So 34 is equal to 2 times this whole thing. 23 minus 3D plus 2D. Go ahead and distribute. Okay, we're going to combine like terms. So this will be negative 40. Subtract 46 from both sides. And this is going to be negative 12 is equal to negative 4D. Divide both sides by negative 4. And I get that 3 is equal to D. What that means is that drinks are $3. Okay. And now we need to figure out what the cost of a pizza is. So you can choose any of these 2 equations, plug it in, and find out the cost of the pizza. I'm going to choose that second one. So I'm going to say 23 plus the cost of a pizza, we don't know what that is yet, plus 3, and we know that the drink amount now is $3. So that's going to be 9. Subtract 9 from both sides, and you get 14 is equal to P. So what that means is that each pizza is $14 and each drink is $3. So let's make sure that works with John's order. 2 pizzas, so that'll be $28, plus 2 drinks, which is $6. So 28 plus 6 is 34. So we know that we're correct. So we can say drinks are $3 each, and pizzas are $14 each. Okay. Now I'm going to have you try a problem that's very similar to this. We're not talking about pizzas and drinks this time. We're talking about coins. So I'm going to read this problem to you, give you a quick hint, and then I'm going to have you try it on your own. Jimmy's mom gave him some coins. There were 15 coins. Some coins were dimes and some quarters. He counted the money and realized he had $2.10. How many quarters and dimes does Jimmy have? Okay, well, before you get started, how much is a quarter? What's the value of a quarter? Hopefully you're saying 25 cents. And a dime? 10 cents. Okay, so use that information to help you. And it looks like you're going to be, well, I'll let you go ahead and pause it. See if you can figure it out. Find those 2 things that you're looking for. Figure out what your unknowns are. Try to write equations and solve. And then we'll resume in just a minute. Okay, hopefully you had a chance to work that out. I'm going to go ahead and talk you through it now. So what we're looking for, this last sentence gives it away. How many quarters and dimes does Jimmy have? So that means we need the number of quarters. And we also need the number of dimes. So let's give some names here. We're going to call quarters Q and we're going to call dimes D. Okay. Now 2 things are happening in this word problem. We're talking about the number of coins that Jimmy has, and we're talking about the value of those coins. So let's start here. Let's talk about the number of coins. We know that he has dimes and quarters, and altogether he has 15 coins. So that means the number of quarters plus the number of dimes is going to be equal to 15. So quarters plus dimes is equal to 15. He counted his money and realized he has $2.10. How many quarters and dimes does Jimmy have? Okay, that's the second piece of information. Now we're switching gears. We're talking about the value of those coins. Okay, well, we know that quarters are 25 cents. So if we multiply 25 cents times the number of quarters we have, that will give us the value of those quarters. So that's what I'm going to do. 0.025, so is quarter, times the number of quarters. Now dimes are 10 cents. So we're going to multiply the value of a dime, 10 cents, by the number of dimes we have. So it will look like this. And we know that the total amount that Jimmy has is $2.10. Okay? I know at this point you're probably good to go. You could solve that pretty quickly. So if you want to fast forward and see if you're correct, that works for me. All right, I'm going to solve for Q up here. So I'm going to subtract a D from both sides. That means Q is going to be equal to 15 minus D. Now I'm going to take what I know Q to be, and I'm going to plug it right in there for Q. So this is going to be 25 cents times 15 minus D, because that's what we know Q is right now, times 10 cents times D. Okay. Now I'm going to distribute. So 15 times 25 cents is going to be, what is that, $3.75? And then we can distribute 25 cents to the D as well. Okay, before I do anything else, I'm going to combine like terms here. So this will be $3.75 minus 15D is equal to $2.10. I'm going to subtract $3.75 from both sides. So I'm going to get negative 15 cents D is equal to negative $1.65. Now I'm going to divide both sides by a negative 15 cents. And I get that D is equal to, well, a negative divided by a negative is a positive, and then 15 cents. I'm going to make this quick. So $1.65 divided by 15 cents is equal to 11. So what that means is the number of dimes that we have is 11. So if we have 11 dimes and we have 15 coins total, how many quarters do we have? You should be saying 4. Okay, let's make sure that also works for this total amount here. Dimes are worth 10 cents, so this would be $1.10. Quarters are worth 25 cents, so 4 times a quarter would be $1. So $1.10 plus $1 is $2.10, so we know that that's correct. So to answer this question, we can say Jimmy has 11 dimes and 4 quarters. All right, Bobcats, that's it for today. Low key, I just wanted to give you some pointers on how to solve these problems, and I hope that that gives you some clarity and that you understand it a little bit better. And please let me know if you need anything. Have a great day, Bobcats.